Welcome, Chemistry 1B, Unit 5, Video Example 4. This is another example of the method of initial rates using this reaction that you see over here and the experimental data that is on screen. Now remember what you're required to do. You need to look and see where we can keep the concentration of one species constant while varying the other species. So where can we keep SO2 constant and vary the concentration of oxygen? And similarly, where can we keep oxygen constant and vary the concentration of SO2? Well, let's have a look at this. Let's have a look and see where is SO2 constant. Well, it's on experiment 2 and 4. All right. And similarly, if I choose another color pen, where is the oxygen concentration constant? It's experiment 1 and 2. All right, so let's do experiment 1 and 2 first so that we can determine the value of M. All right, so how do we do this? We look at the rate at which experiment 1 and 2 changes and we plug in the values. So we see that if we worked out the rate, we get a value that the rate quadruples. If we look at the experimental data, the rate quadruples. You will see that this cancels out and we're left with the values for the SO2. So we see that we get 0.5 divided by 0.25 is 2 to the power m, so m is equal to 2. Okay, then when we look at experiment 2 and 4, we see that the rate triples. Okay, if we go back to the data, you'll see that the rate triples, and we can cancel out these, okay, and end up with the values from the experiment that give us that the rate 3 is equal to 3 to the power n, therefore n is equal to 1. So our final rate or equation is then what we see on screen here, that the rate is equal to the rate constant times by the SO2 concentration raised to the power 2 multiplied by the oxygen concentration. Essentially, that means it is first order in oxygen, it is second order in SO2, and third order overall. Remember, we add the values of the orders to give us the overall order. Okay, and then we can use any one of the experiment values to find the value of the rate constant. So we simply rearrange the rate equation to solve for the rate constant K, plug in the values, making sure that we keep good track of our units, and we can find the value of the rate constant for this experiment.